All right, in this final section, we are going to take a look at parametric equations. So parametric equations are just two different equations to describe an x-coordinate and a y-coordinate. Okay, so instead of one equation that relates both x and y, we're going to have two separate equations, and they're both going to be in terms of t. Okay, now t we call the parameter, but t usually stands for time. Okay, we're usually describing the x direction and the y direction of something in terms of time. Okay, that's usually what parametric equations are used to describe. And we also can describe a direction of motion when we're talking about parametric equations. Okay? And this is called the orientation of the curve. So let's just start by graphing a few of these. To graph parametric, right, all we're going to do is plug in values of t into both of my equations, one for the x-coordinate and one for the y-coordinate. So here we are defining the t values to just go from -3 to 2. Okay, so I'm just going to be plugging in -3, -2, -1, 0, 1, and 2. And I'm plugging those into these equations. All right, so if I plug -3 in here, -3 minus 1 would be -4. And if I plug in -3 for t for the y-coordinate, 2 times -3 would be -6 plus 4 is -2. So that means that the point -4, -2 is on my graph. So -4, -2. Okay? The t value isn't going to show up on the graph anyway. The t value is just how I get the x and the y coordinates. Okay, so we can plug the rest of these values in. So -2 plugging in here would get me -3, and plugging in -2 here would get me 0. Then here, this would be -2, and I'll just finish this out. -1, 0, and 1. And then over here, I believe we are just going up by 2 every time. So 2, 4, 6, 8. So to plot those points then, I'm at -3, 0, -2, 2, -1, 4, 0, 6, and 1, 8. So this, and it just ends up being a straight line. Now, since t is only defined here from -3 to 2, this is the entire graph. It would not continue forever in both directions. Now, if they described the parameters of t as -infinity to infinity, then we would say this continues on forever in both directions. But for this specific example, since t only goes from -3 to 2, this is the entire graph. Now, we mentioned that direction also matters. Okay, so what we need to think about here is the smallest value that I plugged in got me this point. Okay, we can say that this point would be called the initial point, and then the last point would be called the terminal point. So that means I am starting here and ending here. So when we graph something like this, we want to specify the direction. So usually we just kind of put some arrows on the graph like this to show the orientation or the direction that we are moving. Okay, so let's try a couple more. Okay, on this one, our t values go from -2 to 3. So I'm going to be plugging in -2, -1, 0, 1, 2, and 3. And this time, my x equation has t squared minus 3. So if I plug -2 in, -2 squared is 4, 4 minus 3 is 1. If I plug -2 in for y, 2 times -2 is -4, plus 1 would be -3. So that means the point 1, -3 is on the graph, right? And we would say that this is the initial point. Okay, so we can plug these other values of t in. So if I plug in -1, 1 minus 3 is -2, and -2 plus 1 would be -1. If I plug in 0, I will get -3. 0 here, I will get +1. If I plug in 1, -2. If I plug in 1, I get 3. Plug in 2, I will get 4 minus 3 is 1. Plug in 2 here, I get 5. And then finally, plug in 3, that would be 6. And plug in 3 here, that would be 7. So if I plot these coordinates, -2, -1, -3, 1, -2, 3, 1, 5, and 6, 7. So here is what this curve would look like. Okay, so initial terminal down here. So I'm starting at this point, coming up through like this. Okay, and again, I do have a defined starting and ending point. I'm not defining this for all values of t. And we do then want to specify the direction that we are traveling. So we can just put a few arrows on this curve. Now, if I were to extend this all the way out from -infinity to +infinity, this would just be a sideways parabola, or we could think about it as a parabola that has x in terms of y instead of y in terms of x. All right, let's do one more graphing example. So here we've got x is 4 times the cosine of t, and y is 4 times the sine of t. And our t values are going to go from 0 to 2 pi. Now, generally, when we have something like this, we would include all values on the unit circle, but for this, I'm going to just include select values. I'm going to go every multiple of pi over 4. So we'll go pi over 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 6 pi over 4, or 3 pi over 2, 7 pi over 4, and 2 pi. Okay, so if I plug in 0, okay, well, the cosine of 0, again, we can think about on the unit circle, the cosine of 0 is 1. So this would be 4 times 1, or 4. The sine of 0 is 0, so this would be 4 times 0 is 0. At pi over 4, the cosine is the square root of 2 over 2, as is the sine. So this would be 4 times the square root of 2 over 2, or 2 times the square root of 2. And for graphing purposes, it probably makes sense to write that as a decimal. So 2 times the square root of 2 is about 2.8. Okay, so that means this one would be the same. Pi over 2 on the unit circle, cosine is 0, sine is 1. So that means 4 times 0 is 0, 4 times 1 is 4. At 3 pi over 4, we will be at negative square root of 2 over 2, square root of 2 over 2. So that means that the cosine would be negative 2.8, 2.8 for the sine times 4. At pi, the cosine is negative 1. So negative 1 times 4 is negative 4, and the sine is 0, so 4 times 0 is 0. And then as we continue around the unit circle, hopefully we can kind of recognize the pattern that's happening. Right? At 5 pi over 4, both the cosine and the sine are negative square root of 2 over 2. So that would be, again, multiplying by 4, we would get about 2.8. So negative 2.8 negative 2.8. At 3 pi over 2, cosine is 0, sine is negative 1. So 0, negative 4. At 7 pi over 4, the cosine is positive square root of 2 over 2. Sine is negative square root of 2 over 2. So we will be at 2.8, negative 2.8. And then finally, at 2 pi, that would be the same thing as 0. So 4, 0. So if we plot all of these points, right, we go to 4, 0, and then 2.8, 2.8 would be right about there, then 0, 4, then negative 2.8, 2.8. Okay, so plotting all of these points should get me something that looks like this. And if I connect all of those, we should see that this is just a circle with a radius of 4. All right, so x of t equals 4 cosine of t, and y of t equals 4 sine of t is just a circle with a radius of 4. Now we do want to specify direction, right? So we started here, and we started going counterclockwise around the circle. So put some arrows on here to specify that I am going in this direction. All right? So the other thing I want to talk about then is how to eliminate the parameter. Right? Let's take two parametric equations and write them as one equation, right, in rectangular form. In other words, we have y equals something in terms of x, or x equals something in terms of y. To do that, what we want to do is take one of these equations and solve it for t. If I want to write my final equation as y equals something, I'm going to take my x and solve it for t. So to solve this for t, I would just add 1 to the other side and get x plus 1 equals t. So then I'm going to take this and plug it in place of t in my other equation. So that would then become y equals 2 times this x plus 1 plus 4. And then we can just simplify, right? Distribute the 2, 2x plus 2 plus 4. And then this would just be y equals 2x plus 6. Okay, so this is the equation that we looked at in the first example, right? If we look at this, well, this equation, or this line, did have a slope of 2 and a y-intercept of 6, right? So this is that equation in rectangular form, right? So let's try another one. Let's do that second example. Let's write that in rectangular form. So again, if I want to write it as y equals, I'm going to take my x equation and solve it for t. So t squared minus 3. I would add the 3 over, and then take the square root. So whenever we take the square root, we need plus or minus. So we would have plus or minus the square root of x plus 3 is equal to t. So now I can take this and plug it in place of t over here. So y equals 2 times plus or minus the square root of x plus 3 plus 1. So really the only thing I can do to clean this up just a little bit is since these are being multiplied, I can just pull this plus or minus out front to make it look a little bit nicer. So plus or minus 2 times the square root of x plus 3 and then plus 1 outside. So this would be these two equations put together parametric, or put together in rectangular form. Now I do want to show you how we could do this one a different way. Okay, I could have instead solved this equation for t. Okay, so let me come down here and do that. Okay, if I've got y equals 2t plus 1, well, I can subtract the 1 over and then divide by 2, and I would get y minus 1 over 2 equals t. And I can take this and plug it in place of t in my other equation, in my x equation. So that would then become x equals y minus 1 over 2 squared minus 3, like that. And if I want to multiply this out, right, if I'm squaring a binomial, we would square the first, take 2 times the product of the 2, so that would just be minus 2y, and then square the last, all over, I would need to square the denominator as well, right? So 2 squared is 4, minus 3. So then if I want to combine these, I can write 3 as 12/4, right? So that I get common denominators. And then I can combine my like terms. So I could say this is y squared minus 2y minus 11 over 4. So this question actually did not specify how we needed to write our final answer, right? So this could be a final answer, or this could be a final answer. Now, we do want to pay attention, though. A question could specify, write your final answer as a y equals or as an x equals type of thing, right? But either of these would be correct rectangular form equations that combine these two parametric equations, right? Then our final example is just a little bit different, right? Here, since I have my x and my y written in terms of cosine and sine, what we actually want to think about is our Pythagorean identity. Cosine squared plus sine squared equals 1. So what I want to do here is actually solve each of these equations for cosine and sine. So when I do that, if I've got x equals 4 cosine of t, well, I would just divide by 4 and get x over 4 equals cosine of t. Very similar for y. Right? If I've got y equals 4 sine of t, and I just divide both sides by 4, we would have y over 4 equals sine of t. Okay, so then what I can do, I guess actually I should have used t as my variable here instead of x. What we can do is replace cosine of t with x over 4. So this would actually become x over 4 squared plus y over 4 squared equals 1. Now, if I square everything, I would have x squared over 16 plus y squared over 16 equals 1. And I could finish by multiplying everything by 16. If I multiply both of these fractions by 16, the 16s would cancel out, and I would just get x squared plus y squared, and then over here, 1 times 16 is 16. So this is the equation of a circle, right? X squared plus y squared equals r squared. And that is what we found when we graphed this, right? We said this was a circle of radius 4. And that is what this equation would describe, right? The last thing I want to show you is how to put in parametric equations into a TI-84 calculator and into Desmos. Okay, so let's start with the calculator, right? On the calculator, if you go to Mode, this option down here, where we already talked about going into polar, we can actually go into parametric mode. So if I hit enter here, I can go into parametric, and then if I press y equals, we have an x and a y in each spot. Okay, so we can put in any piece that we want. Let's type in that first one that we used. Okay, let's do t minus 1 and 2t plus 4. Okay, so t minus 1, and again, notice this button here that is x if we're in function mode, or theta if we're in polar mode, is now t if we are in parametric mode. Okay, and then this one was, what was it? 2t plus 4. So 2t plus 4. And if I graph, we see that line. Now, if I want to go to window, and I need to specify what my t values are. Okay, so in this case, we said we want to go from, -3 to 2. So this is where I would put that information in the calculator. -3 up to 2. And then it just shows me that piece of the line that we graphed. Okay, so change your mode to parametric mode, and then y equals will appear like this. And if you go to window, you can specify where you want to start and where you want to end by the t-min and t-max. Okay, so to graph using Desmos, what we need to do is type this in like it is a coordinate point. Okay, so I'm going to type in a point, and for my x coordinate, I'm going to put my equation in terms of t. So for this one, if I want to do t minus 1 for my equation, I'm just going to type in t minus 1 here, and then comma 2t plus 4. And that gives me my parametric curve. And then automatically it pops up with the parameters for t. So again, we said we want to go from -3 to 2. So I would type in -3 up to 2. And I can see that line shown on the graph. Okay, so that is it for this video. The final question is going to pop up asking you what questions you have.